Hi, my name is Paul Andrew. I'm a program manager on Office 365 at Microsoft. And today we're going to be talking about network connectivity. Specifically, this talk is Microsoft 365 network connectivity testing tools. And we're going to take a look at two tools available to help you with testing your network connectivity between your users and Microsoft 365. The first tool is the Microsoft 365 Admin Center and the network connectivity page in that. And this is going to provide a network assessment for your connectivity to Office 365 and also network insights that can help you to improve the network connectivity. We're looking specifically at network connectivity that impacts the user experience with Exchange Online, with SharePoint Online, and with Microsoft Teams. So we have specific tests which are known to affect the user experience. So when you follow one of our network insights, you're going to be improving user experience. We need to do these tests at the user location. It's very important to identify the user location because it's at the user location where network connectivity and that network perimeter is. It's not like a whole tenant-wide thing. You've got to find out where that connection is to. The second tool that we have is the Microsoft 365 Network Connectivity Test Tool, and we'll take a look at that after we've looked at the tooling in the Admin Center. The reason we have this tooling is because we want to help you to align with best practices and these Microsoft 365 network connectivity principles. We have four principles. The first one is to identify and then optimize Microsoft 365 traffic. And we provide the FQDNs and IP addresses for all of Microsoft 365 so that you can identify traffic coming from your users going to Microsoft data centers as part of your Microsoft 365 subscriptions. Other traffic may be random internet browsing that your users are doing or something else, but we're particularly concerned about the user experience with Microsoft 365. It tends to be a large portion of our customers' network traffic, and it can be sensitive to network connectivity design issues. And so we've got to identify that first so that we can optimize it. There's three ways that we recommend optimizing it. First, having local egress from the user's location so that network traffic gets out onto the internet and it connects onto Microsoft's network as soon as possible. The second is having direct connectivity, so not connecting through a network intermediary like a cloud proxy server or a cloud security service. You want to bypass that kind of stuff for Office 365 traffic. It's just going to make for a hairpin, a longer network connection, additional processing, which is going to impact the user's experience. The third thing you can do, and our fourth principle, is to modernize network security for SaaS. And this means putting network security into the application, using the built-in security that's part of Office 365, thinking about what zero trust means, so not trusting your network connection, but trusting security reviews that are in the data plane or part of the application. So I mentioned that it's very important to identify the location where your users are, and all of this network connectivity is specific to a location. So we have three methods that you can identify the location where your network connections are coming from for your users. And depending on your requirements, you may choose one of the three. Let's take a look at the pros and cons of each. The first is to enable Windows location services on your client PCs. This means that you can have Office 365 client applications, get the location, the Office location where the user is, and submit that as part of the network telemetry. Now, this means you must have enabled and consented to Windows location services on each machine. We do obfuscate the location to 300 meters by 300 meters because we're interested in the Office location, not the person's location. The results are further aggregated over 3 days and to each city. So you're going to see one Office location per city. And these results aggregated over 3 days are updated every 24 hours. Let's compare that to the next one, which is entering Office information and the LAN subnet IDs that are part of that. For this, you have to enter all of your Office locations and specify the LAN subnet IDs. You can upload this with a CSV import function that you have. You can enter multiple Office locations with different LAN subnet IDs in a single city, something you can't do with Windows location services. These results are also aggregated over 3 days and they are updated every 24 hours. The third way is by running our standalone tool, the Microsoft 365 Network Connectivity Test Tool. And using this tool, you can ask a user at each location to run the tool and submit the tests into your tenant. By doing this, you can see those results in the admin center, and you can get network insights and network assessments based off those results. The user can choose to use Windows location services in their browser, or they can type in their location and associate that with their test. This has some additional tests that you can use. We test DNS, proxy servers, VPN, buffer bloat, and all of the required FQDNs that Office 365 requires. The results are not aggregated. You run a single test appears. That means that we are not running them every day. It also means you don't have to wait for that overnight aggregation. So they're going to appear within a minute of the user submitting them. They're not going to be ever aggregated. You just see one result test that you've asked the user to run. If you want another test, you have to ask a user to go and run that as well. Okay, so 3 different methods. Depending on what you choose is going to depend on your environment. You may choose to use multiple of these, and I'll show you how you can use them together. Here's the Microsoft 365 Admin Center, and you can see that I've already switched over to the network connectivity page here. Let's take a look. The first thing I see is I've got a map, and this map is showing my office locations, and each circle on the map represents one of my offices. The size of the circle indicates how many network measurements that I got. It's also going to indicate how many users are at that office, and the color of the circle is indicating the network assessment. So the network assessment is this dark plum color here for this location. And the first thing I want to do is go and find out why is that so low. So Philadelphia office, let's click in that. Here's the detail for the Philadelphia office. It's showing me about 16% of my users or samples are coming from that office. And there's a map here showing the network perimeter as identified by the tests that we have run. So here's the user location in the Philadelphia office, and they've got this line going all the way across the country to the network egress for users in that office. So this indicates that the office has a WAN, which is backhauled all the way across the US, and this is going to take some time for network traffic to run across it. It's going to impact user experience for those users. They're using Office 365 Service Front Doors for SharePoint and for Exchange over on the West Coast there. We do have Service Front Doors for SharePoint and Exchange on the East Coast, but those are not able to be used by this customer because of that WAN backhaul and their network egress over on the West Coast. All right, what else can I see? I've got an assessment of 18 of 100 over here, so it's pretty low. I've got a breakdown by workload showing me 312 milliseconds for TCP latency to connect to the Exchange Online front-end server. I'm able to get 4 megabytes per second of download speed to the SharePoint Online front-end server. That represents about 40 megabits per second. The 4 megabytes is indicating that from a user's machine connecting to the SharePoint Service Front Door or the OneDrive server that they connect to, they could download a 4 megabyte file in about 1 second. Microsoft Teams, I've got my UDP measurements. UDP is used for audio and video in Microsoft Teams, and we're measuring the UDP latency, UDP jitter, and UDP packet loss. All of these are important and come back to calculating this Microsoft Teams assessment that we have. You can see here I have a history of the network assessment going back 30 days. I can see what it's been doing. I have a panel here showing me a comparison of my network assessment to other Office 365 customers in the same city. So you can see my network assessment, which was pretty low, is down here in this bottom bucket. And the best customers in this city have a network assessment between 80 to 100. It's about 24% of those. This indicates that there is opportunity with the telecommunications infrastructure that I have in this city available to me that I could get a much better performance. Over here are my network insights, and these identify what we have found from our testing that could be improved with the network connectivity for users in this location. Here's my identification of backhauled network egress. And if I want to find out what I can do about that, there's a flyout that I can click on. It's got a doc page specifically about this network insight. It shows me the data points which we use to figure this out. This is key here, 2,371 miles between my user location and my network egress onto the internet. This is a pretty long way, and we're going to flag that you don't have local egress for any network egress that is over 500 miles. All right, so you can figure out what to do about it there. And that's the summary view of my location. I can also go into this details view and see the specific tests that were collected if I want to get more detail about any of the information that we collected and aggregated for this location. So you can see what I have. Here's my network egress location, the 2,371 miles again, the number of customers who have better connectivity in my location. Here's the data for Exchange. It's showing me where I am connected to from my user's location in Washington State in the United States. I'm getting a TCP latency of this 312 milliseconds. It says I have a potential improvement of 280 milliseconds. This is calculated by looking at the most optimal TCP latency that's available to me with one of these optimal service front doors, and then taking that and subtracting it from what I'm actually seeing. So I must have an optimal TCP latency of about 32 milliseconds here for a pretty significant improvement if I could get to one of those closer service front doors. For SharePoint Online, I have identified my service front door, and I've got that 4 megabytes per second download speed, and here's the optimal service front door on the East Coast again. Here's the data for Teams Online showing those UDP measurements for me. The third tab I have here is I can look at the history of my network assessment data. I can take a look for different attributes that I have, and I can go back up to 2 years of data that has been collected from those test probes and compare what I have now to what I have over time. These data points are collected each day, and you can use it to identify when a network improvement project is making an improvement to your network assessment and therefore your user experience. All right, lots of great data there. Now, this location, Philadelphia, was identified for me by Windows Location Services. So let's carry on and take a look at what else we have here for the tenant and then see what other locations we have. Here's the current assessment of 56 by doing a weighted average across all of my locations. I really need to see the data for my locations to see what I can do to improve. But just as an aggregate view, I've got this 56 number here. It also shows how that number is broken down by each workload. I've got the history there as well. And I've got a summary of my network insights and how many locations each one is found at. There's also a table of network insights, and I can get a table of my network locations here. So we looked at that Philadelphia location, and you can see it's got this icon as a city. A city comes from the network telemetry that comes from Windows Location Services. I can also add a location and specify the LAN subnet ID. So this is the second kind of location. Let's add Sydney in here, and it finds it from the suggested list. And then I can go in and add my LAN subnet ID for that location so that it can correlate test results with this location. You can see here there's a suggested list of these, which comes from the data that we're already receiving from your tenant. We can see that you're using 10.0.3.0, and I'm specifying that that is the one for Sydney. So let's go ahead and save that. If you had multiple locations using the same LAN subnet ID, then you could differentiate them by egress IP at this location. We don't have to do that here, so I'll just save the location. It appears on my list. I don't have any samples collected or any results yet because that's going to aggregate overnight for the past 3 days, but it's going to do so for that LAN subnet ID that I specified. If I don't want to enter all those through the user interface, I can import my cities and specify the LAN subnet ID there. There's a template, and which actually more than a template, it includes the headers you need to use for the CSV file and also our current data that you have there. So you can download that, you can add locations to it and then browse and upload it. And that will give you a way of adding locations maybe from another system that you have. And once you've formatted for those CSVs, you can upload them. Here's a location which is specified using the LAN subnet ID previously and has aggregated. So you can see it just looks the same. It's got the same data. In this case, they are aggregated by LAN subnet ID rather than aggregating by Windows Location Services. So all good there. Now, I mentioned that there was a third way of adding locations, so we're going to go over to the Standalone tool and take a look at that. All right, here I am at the Microsoft 365 Network Connectivity Test Tool, and this is located at connectivity.office.com. And all you need to do is tell someone at the location where you want to get the test from to go to that website, sign into the tenant, and scroll on down and click Run Tests. You can see that they can choose between having their location automatically detected or typing it in. They can also optionally add the domain for their tenant, but they can also just go ahead and click Run. Now, it's selected Detect My Location, so my browser is asking me for permission there, and I'll say yes. And now it's running some JavaScript tests for network performance. And once it's done with those, it's going to ask me to download this executable that runs a number of additional tests on my local machine. Okay, so while we're running those tests, we can go ahead and sign into our tenant. Let's do that so that we can have the results uploaded. Okay, so we're signed in, and what that means is once the tests are completed, it's going to go ahead and upload them. Let's take a look at our tests running. There's just a couple left now, so while we're waiting for those last ones, let's take a look at what we've got. The user interface here updates while the tests are running. Each test that completes, it goes and updates it. It shows here that I am in this top bucket of performance for my location. It's showing me the network perimeter on the map. Here's a new icon which we didn't see on the tests that come from Office 365 clients and are aggregated. This is showing me my DNS recursive resolver. Now let's dive in and look at some of the details. You can see my location. I am located in the city of Redmond, Washington, United States. My network egress is also in Redmond, Washington, so there's my distance 0 between the two. There's no significant number of customers with better performance. Here is looking at my local DNS servers. The time to make a DNS request is recorded there. Also, the distance to my DNS recursive resolver. That was the DNS server that you saw added on the map. It looks like it's just gone over our threshold of 25 milliseconds. We'll see in a moment whether that's impacting my performance or not with some other data. There are these additional tests in addition to DNS, which are not available in the aggregated tests, but are in my standalone test. It's checking for proxy servers impact. I don't have a proxy server. I do have a VPN, which it's detected, and it's showing me that my VPN is correctly configured for Office 365. So my Exchange, SharePoint, and Microsoft Teams connectivity is split out, rather than being tunneled down that VPN, which can really slow down your Office 365 user experience. And then here's the similar data for Exchange and SharePoint and Teams. We've got this front end server that's identified. Quincy for Exchange, it shows me the latency. Here's the optimal service front doors. I'm doing great there. And there's a piece of debug information for the DNS record that I'm connected to for my service front door. SharePoint, here's the same thing. There's the service front door I'm using. Here's my download speed in megabytes per second. Buffer bloat is interesting. This is telling me that while a download was going on, I actually had a slightly slower latency connecting to the SharePoint service front door. When your network is not loaded with downloads, you often can have better latency, and that additional latency can be caused by sometimes consumer grade routers that you might have or other congestion factors. In this case, it's not very much. It's not worth worrying about unless it's significantly over 100 milliseconds. It can be thousands of milliseconds sometimes if your consumer grade routers are buffering up packets for a long time before they send them on. Here's also the debug information for the DNS of my front-end server for SharePoint that I'm connecting to. Here's my Teams measurements that I took. And there's two other tests that we don't have in the aggregated test results with those other methods. One is connectivity to the required FQDNs for Office 365. And the second is trace routes to the service front doors for Exchange, SharePoint, and Microsoft Teams. All right, so my test is finished now. I can also share these test results just with anyone using a URL. And when I copy a link, Here's a link to my test result, which I can share with someone else to get their advice about it. I don't need to share that with my admin. My admin's going to already have that because I'm signed in. I can also see the historical reports that I've run. Here's the report that I just ran right now, and I could choose to delete that. I can also go back and view it and share it with other people. All right, let's take a look at this report that's been submitted back to the Admin Center. Here I am back in the Admin Center, and the report is submitted right away. I just have to refresh this page, and you can see I can view that report. It's ready for me to take a look at. And so this is for Redmond, Washington. When I click in and review that report, I can see now that there's two options. I can have this user submitted report or the collected samples report that I had previously. Here's the collected samples report showing the network perimeter on the map. And if I click over to the user submitted report, you can see the network perimeter for that, showing this additional DNS recursive resolver. I'm also seeing the different network assessment there that I have, and I can see the comparison to other users, which is slightly different for that one-time run as compared to the sampled data. Here's the user that submitted the report. It was from me. And when I take a look at the collected samples, you can see that they were run just yesterday. When I go into the details, I can actually compare these two side by side. My user submitted report, which was in Redmond, Washington, and had local egress in Redmond, Washington, and my collected samples report, which had local egress in Woodinville. Each of the data points which is tested with both types of tests is shown side by side, and you can see these additional ones, DNS, proxy server, VPN, which aren't available in the collected samples but were in my one-time run. Similar for Exchange Online, we can compare those. We can compare them for SharePoint and Teams. And the connectivity tests and network path, which were only available in the user submitted report, are shown there as well. All right, all great stuff. So whichever way you choose, you can get access to your test results and compare those across your different locations. Okay, so what did we look at here? We took a look at the Microsoft 365 Admin Center network connectivity page, and we looked at three different ways that you can get test reports for network connectivity, network assessment, and network insights testing to appear in this page. The first one was with Windows Location Services, where the cities are auto-detected where you have users. That's great. The second one was by entering LAN subnet IDs for each of your office locations. This allows multiple office locations within a city, and you can import that data with a CSV import, because you've got to enter it some way. If you don't want to use the user interface, CSV import is a good choice. The third way is to ask a user to go out to each site and have them run connectivity.office.com, the network connectivity test tool. And that adds some additional tests, but it is a one-time run test. We just show you what that user ran, and those tests stay there. If you want another run, you've got to have a user go out there and run it again. All right, all of this data and this network assessments roll up to the productivity score in the Microsoft 365 Admin Center. So here's a screenshot from the productivity score. You can see the network connectivity panel there. The network assessment rolls up into the technology experience as part of the productivity score. So if you make improvements to your network connectivity for your users, as you might expect, that's going to drive a better user experience, and your productivity score is going to go up. In the productivity score, you can click into network connectivity and review the individual locations and our network insights and recommendations for how you can improve your networking at each of those locations. We are announcing a public preview for network connectivity at Ignite 2020, and I encourage you to try that out. If you go to aka.ms/netignite, you can find out more details about that. You can also go into the Admin Center, go to the Health menu, select Network Connectivity, and you can click through and sign up for the public preview right there inside of the Admin Center. This video is part of a series of network connectivity and network performance videos. You can check the other ones of those at aka.ms/netvideos. And we have a forum for discussing this. It's in public preview. We encourage you to go and discuss what you learn. Tell us your feedback. Let us know if you have any issues in this forum, which is at aka.ms/netforum. Hope to see you there in the forum. Thank you very much for watching today, and I hope you will give us lots of feedback about this. Again, my name is Paul Andrew, and I'm a program manager in Office 365. Thank you very much.